So, according to the Ohm's law, we already know the formula. Let me take one pen. We already know the formula. V, the voltage, is going to be the product of the current, electricity current, time resistance. Okay, but now here says find the current, I, in the given circuit. If we divide everything by R, this equation, this implies the current, electrical current, I, is going to be equal with the voltage divided by the resistance. So V divided by R. Okay, so the voltage here is at 12 volt, and in this resistance is 3 ohm, and the other resistance is 4 ohms. So now we want to find out the intensity here, the current, electrical current I. So let's say I is here. This is a I. And now this I is going to go in two branches. Here is a I1 is going to this resistance, I1. And in this other one is going to be I2, the current I2. So that's what it's going to be. So now if we look to find the R, I is 1 over R here. But the R, as we see here in this case, R is in parallel, and the resistance here, 1 over R, is going to be equal with 1 over R1 plus 1 over R2. So let me write here R1 plus 1 over R2. Okay. And now, if I want to find the resistance here, how am I going to find? I'm getting here the common denominator for R1, R2. And if we are going with the cross product, R2 is going to be time 1, R2 plus R1 divided by R1, R2. So 1 over total resistance, RT, let me write the R, is going to be equal with this R1 times R2. Okay. And on the numerator is going to be R1, R2 plus R1, but because commutative property works, let me write R1 plus R2. And if I'm taking now reciprocal in this side and this side, so R is going to be equal with R1 times R2, because the reciprocal of R1 plus R2 divided by R1 times R2 is going to be R1 R2 divided by R1 plus R2. So this is what is going to be here, R1 plus R2. And now if we find the total resistance here is going to be equal, R1 is 3, R2 is 4, 3 times 4, 3 times 4, ohm square, ohm times ohm is ohm square, and down is going to be equal with 3 plus 4, 3 ohm plus 4, so 3 plus 4 ohm. Plus ohm, and square with ohm goes away, 3 times 2 is 12, is 12 divided by 7 ohm. 12 divided by 7 ohm. So this is 12 divided by 7 ohm. And now we want to find the E here, the total current. So this current I, the total current I is going to be equal with the voltage. So the voltage is at 12 volt. Okay, divided by 12 over 7. 12 over 7, but here is a ohm. 12 over 7. And now here at 12, with the 12 we can simplify. And when we do some algebraic calculation, I is going to be equal with the 7 ohm over volt voltage, volt over 7 volt over ohm, which is ampere, is going to be equal to 7 ampere. Because the voltage divided by ohm, the units give us ampere, so it's 7 ampere. So this is a total intensity here, equal to 7 ampere. So let me write here, I is equal to the 7 ampere. But if we want, for example, to make a little bit sure here, so let's say this is a I1. I1 is equal with the, let me write it with a different color. So I1, if you are taking just I1, is going to be equal with the voltage divided by R1. Okay, and I1 is equal with the, because the voltage here is a 12 volt divided by a 3 ohm. So this is going to be equal with the 4 ampere. So I1 is going to be equal with the 4 ampere. Okay, 4 ampere. And we are taking, for example, I2. I2 here is going to be equal with the voltage divided by resistance 2, R2. So this is a, because the voltage is a constant, in both resistance is the same voltage, divided by R2. And this is 12 divided by 4. 12 voltage divided by 4 ohm. So I2 is going to be equal with a 3. 12 divided by 2 is 3 ampere. So those, and it makes sense because we said this is a 3 ampere and this is a 4 ampere here. Okay, and it makes sense because the 4 ampere plus 3 ampere total current electricity is a 7 ampere.